different ways. We've looked at the graphs. On the graph, what are we looking for our solutions? What are the solutions on the graph? Where it hits the x-axis are the solutions. If you're looking at an equation, what did we have to do? Well, what have we done the past couple days on these? Yeah, we have it equal to 0. So then we had to factor. And then the only way you can get 0 in a multiplication problem is if one of those factors is 0. And so I just want to kind of look at this for a few minutes and talk about how this is related. So if I am looking at this graph, okay, remember we had different forms for our equations. Vertex form was that y equals a x minus h squared plus k. Standard form was the ax squared plus bx plus c. So if I'm looking at it, vertex form was when we were using our transformations. If I'm looking at this one, we know that a normal quadratic kind of starts at 0, 0. How did this one get moved? It went what? Up, down, left, right. Come on. Down and left. How far down did it go? 9 down. So on the equations, the down was represented by just a number on the end. So moving it down 9, just put a minus 9 on the end of our equation. How did we do the left or right? Where did we look at for those?
X minus.
Right. So if it was, remember, if we added, it moved to the left. And if we subtracted, it moved to the right. So in order to move this to the left one, it had to be an x plus 1 in parentheses. So the vertex form of this was x plus 1 squared minus 9. Now we didn't really talk about it, but do you think there's a way to get from vertex form to the standard form? Are they related? Yeah. What does it mean when I say x plus 1 squared? It means that there are 2 of them. So this would be like x plus 1 times x plus 1. Okay. If you have that twice, what would you have to do here? How do we multiply those? Yeah, the FOIL. We get x squared, 1 times x is x, 1 times x is x, 1 times 1 is 1, and we still have that minus 9 on the end. And so when we combine like terms, we have x squared, 1x plus 1x is 2x, 1 minus 9 is negative 8. So that's what the standard form would look like. Is she emailing me? Okay. So vertex is just when we can easily see the transformations. Standard form is when it's all multiplied out. Factored would be like if I went to this, the x squared plus 2x minus 8. Can we factor that nicely? We're looking for 2 numbers that multiply to negative 8 and add to a positive 2. What numbers would those be? Yeah, positive 4, negative 2. So we get x plus 4, x minus 2. All right, these are three different equations for the same graph. And if you plugged any one of those into your graphing calculator, it would give you the same graph. We can also look at this. On this graph, what are the solutions? The x-intercepts? Positive 2 and negative 4. Look at my factored form. What makes x plus 4 equal 0? Negative 4. What makes x minus 2 equal 0? Positive 2. So this is all related. It's not like we're doing something different all the time. Okay, we've looked at different ways we might see the equation, but it's all connected. Questions on that one? So we're only going to do a few of these. I just want you guys to really understand that this isn't just all separate stuff, it's all related. And then we're going to do some reviews specific to the quiz for tomorrow. So if I look at number 2. All right, if I am trying to create an equation for this graph, we have the EOC coming up. They love to do that. Give you a graph and ask you to find an equation for it. Normally the vertex is here. Which direction did I move? I went right. Okay, to move left or right, it has to go inside with the x. So how far right did we move? 7. So it would be x plus 7 or minus 7? Minus. The x does the opposite of what you think. So moving in the positive direction actually subtracts. And then the graph moved how else? Down 1. So it has a minus 1. All right, if I asked you to get the standard form, what would we have to do at this point? That square means there's 2 of them. So if we FOIL, we get x squared minus 7x minus 7x plus 49. And there's still a minus 1 on the end. So if we combine like terms, we have an x squared, negative 7 and negative 7 is negative 14, and 49 minus 1 is 48. If I asked for the factored form from here, that's when we have the parentheses. So I need 2 numbers that multiply to a positive 48 and add to a negative 14. Negative 6 and negative 8. So x minus 6, x minus 8. If I look at my graph, what are my solutions where it hits the x-axis? Positive 6 and positive 8. If you set x minus 6 equal to 0, do you get positive 6? Yeah, if you set x minus 8 equal to 0, we get positive 8. So we can tell the zeros from the graph or the factored form. All right, I want you guys to try one of these. Well, actually, I'll get started with you and then I might have you finish it. On number 5, I gave you the vertex form, and I want to see if we can create everything else from it. So if we look at this, thinking about our transformations, what does a plus 1 on the end do? Up 1. What's the minus 1 do? And what does the negative in front do? So normally it starts here but I have to go right and up, so that's going to be my first point. And then it's normally facing up, but it's going to be facing down. Now, I would probably need some more points. How did we get points on these? What did we usually
Put
use?
it into the graph.
Yeah, we used our graphing calculator to get some points. So we could certainly do that. You can plug this original into your y equals. So let's do that and make sure we've got some points to get a good graph here. So we have a negative x minus 1 squared plus 1. We can look at our table feature, and it tells us some points. 1, 1, 2, 0, 3, negative 3. If you wanted, you could go 4, negative 8. And we know we can go the other direction as well. Okay. If I asked you to get the standard form from this, what would we have to do? How have we gotten the standard form on the others? We have a negative out in front. We have x minus 1 times x minus 1 plus 1. So if I FOIL here, that's x squared minus x plus 1. We still have this plus 1 on the end. Because there was a negative, you have to distribute that to that whole parenthesis. So we get negative x squared plus x minus 1 plus 1. One x plus 1x is 2x. Negative 1 and positive 1 cancel. So we just get negative x squared plus 2x. How did we factor something like that? GCF, what can we take out of all of those? The x. So you could see it written like this. You might have also taken out a negative x. So you could see it written like this. Those are equivalent. So really all we're practicing here is just kind of reinforcing what the graph looks like. What does vertex form look like? What is standard form? What is the factored form? Notice the points where it hits the x-axis here are 0 and 2. If we set x equal to 0, we get 0. If we set negative x plus 2 equal to 0, we get positive 2. So tomorrow, I said we had a quiz over solving our quadratics. So I have created a review for you that is very similar to your quiz. I'm trying to give you guys plenty of time to work today. I know we've had a lot of people absent trying to catch up. So I want to make sure you have time to work on things. You're going to have a couple that you do by graphing. So on the graphing ones, what did we have to do to get our starting point? What was that formula we used to get that first one? Negative b over 2a. Remember, to get the vertex. And then we use that table feature to help us. And what are we looking for on the graph if I ask you for the zeros or the solutions? What points am I asking you to list them at the end? Where it hits the x-axis. And then the other ones are the factoring problems, like we've done the last couple days. So there's some that are GCF, some that are slip and slide, a little bit of everything. So I want to give you time. This is what your quiz will be like tomorrow. Ask me questions. Let's make sure that we are prepared.